So we talked about the quantum mechanical model of the atom. Now we're going to talk about how that model explains the behavior of atoms and elements and compounds. So the chemical properties of elements are periodic. We learned that from the periodic law.
We did.
Hey guys. Shh. We learned that from the periodic law. And the reason that the periodic law exists is because the number of valence electrons is periodic. And so we've observed that elements in the same column have similar properties, and that pattern repeats, and it's because the number of valence electrons is also periodical. Okay? So let's look at some of those patterns. So the noble gases, group 8A. All of the noble gases, except for helium, the little guy, they all have 8 valence electrons. And because they have 8 valence electrons, they have some common properties. Helium and neon are practically inert. Almost no compounds for those. What we see is that when atoms have 8 valence electrons, they are unusually stable. So if we think about the quantum hotel, there are bonuses involved when you have a valence level that's completely full, 8 valence electrons. 8 people on that floor. So that's a lowering of energy. Lower energy is more stable. So what we're going to see, back up to this a minute, in a slightly different analogy, I think of the noble gases as being like the in crowd in high school. The cool kids that everybody wanted to be part of that group, right? And one of the things that people would do, I remember watching my kids do this, is they'll dress like the cool kids, right? Even if they aren't one of them, they'll like wear the same clothes. So these elements are the ones that all the others are trying to be like. In terms of atoms, the electrons are on the outside, so those are like the clothing of the atom, and the personality or the soul is the number of protons. So an atom cannot change which element it is, but it can change its number of electrons by becoming ions. So when we look at the alkali metals, these all have 1 valence electron in that S sublevel. These elements are really, really reactive. Sodium, potassium, they'll react with water explosively. The reason is that by losing 1 electron, then they have 8 valence electrons and are stable like the noble gases are. And so they will react very, very easily to get rid of an electron. When they lose an electron, they form +1 ions. And so we learned earlier, when we were talking about nomenclature, that the group 1A metals form +1 ions. Well, there's a reason for that. They do that because when they lose that 1s electron, then they have a noble gas configuration. So they become more stable. So these elements are like, the kid, his mom made him wear a sweater to school, and the sweater is not what the cool kids are wearing. So what does he do? The least chance he takes the sweater off, now you can see my cool Nike t-shirt or whatever, right? So they're going to change the number of electrons to become like the noble gases. On the other side of the noble gases are the halogens. All of the halogens have 7 valence electrons. So they're 1 electron short of that magic number 8. So what do? They will react to gain an electron. And so these elements are also quite reactive, but they tend to gain an electron. When they form ions, they form anions with a -1 charge because they do so by gaining an electron. You gain 1 electron, and now we've got the valence shell full. Any questions? I get these slides all combined in my head, so I've kind of already talked about this. Some metals do form more than 1 kind of ion, but right now we're just going to talk about the ones that only form a single ion. The nonmetals only form 1 kind of ion, and it's predictable from the position on the periodic table. Group 1A forms +1, group 2A is +2, group 7A is 1-, etc. They do this because when they form those ions, they have an electron configuration that is the same as the nearest noble gas. Here's a periodic table from your book, and even in the new edition, they've got the period numbers wrong on this. Because what's missing here, period 1 is missing with hydrogen and helium. We're just leaving that off and looking at the rest. So don't be misled by the numbers that the book put there. But here, for group 1A, all of these guys form +1. Because they lose one valence electron, and sodium loses an electron, and now it becomes like neon. It doesn't become neon, but it becomes like neon, right? Yes?
How come zinc and silver isn't added in there for predictable?
Okay, so zinc and silver aren't in there because we can't use this same explanation of losing or gaining electrons to have the noble gas configuration. They are predictable, yeah. But they're predictable because we memorize it. Yeah. Aluminum is predictable because how many valence electrons does aluminum have? It's in group 3. It's got 3. So it loses 1, 2, 3 electrons. Now it has the same number of electrons as neon. They're going to be arranged in the same way. It'll have 8 valence electrons. So when we look at anions, we can write their electron configurations. So anions form when nonmetal atoms gain enough electrons to have 8 valence electrons. So let's look at sulfur. So here's the electron configuration for sulfur. We looked at how you can find sulfur on the periodic table and predict that its electron configuration ends with 3p4. So what we want is for sulfur to have 8 valence electrons. Remember, the valence electrons are those with the highest principal quantum number. So these are the valence electrons. Right now we've got 6. We add 2, like we've done here, and now it has 8 valence electrons. The electrons are just like argon.
So you change the P4 to 6?
Yeah, so we change this P4 to P6. We gain 2 electrons. That changes the charge on this. Yes?
Are they doing that because they're trying to achieve octet?
Trying to achieve an octet. 8 electrons is called an octet. So 8's kind of like a magic number. I tend to personify atoms, and so they want to be happy, and the way that atoms are happy is to have 8 valence electrons. They want to look like the noble gases. So same electron configuration as argon. It does not become argon. It still has the same number of protons. It just changed the outside. For cations are formed when electrons are lost. And for the predictable main group metals, they lose all of their valence electrons. So let's look at magnesium. So here's the electron configuration for magnesium. It has 2 valence electrons, right here. It wants to look like the cool kids. It wants to look like the noble gas. The noble gases have 8 valence electrons. So it loses those 2 electrons. Does it have 0 valence electrons now? No. We've taken off the electrons in the 3rd level. Now the highest level is the 2nd level. Okay, so here is after we've lost those 2 electrons. Now the highest level that has electrons in it is the 2nd level, and there's 8. Same electron configuration as neon. Same number of electrons. It's got a charge now, though, because the number of protons doesn't change. Any questions?